Questions 21 to 25 on the 2005 Grade 10 AMC 10B. 40 slips are placed into a hat, each bearing a number 1 to 10, with each number entered on 4 slips. 4 slips are drawn from the hat at random and without replacement. Let P be the probability that all 4 slips bear the same number. Let Q be the probability that 2 of the slips bear a number A and the other 2 bear a number B not equal to A. What is the value of Q over P? Let's first figure out P, then we'll figure out Q, and then we can figure out Q over P. So P, it's a probability, and therefore the denominator will be the total number of ways of doing what they're asking us to do, which is choosing 4 slips out of 40. 4 slips out of 40. And we do that in the following way: 40, choose 4. And the numerator for P is where all 4 slips have the same number. So that means you've got 1, 1, 1, 1, or 2, 2, 2, 2, and so on, all the way till 10, 10, 10, 10. And obviously there's 10 ways of that happening. So there you go, there's P. Q is a little bit more complicated. Q is a scenario like 2277. So you have a number that's on 2 slips and another number that's on the other 2. So the first thing we have to do is, from the 10 numbers, we have to choose 2 of them. So 10, choose 2. And then, like I did here, I chose 2 and 7. From all the 2's, you'd have to choose 2 of them. So how many 2's are there? Well, there's 4. Each number is entered on 4 slips. So from the 4, you have to choose 2. That's for the first number. And in a very similar way, for the other number, there's 4 of them, you've got to choose 2. So that's how you figure out Q. And that's, of course, the numerator. The denominator is the same as P. From 40, choose 4. All right, so that's basically P and Q. Q over P is this into a fractional form. So before I figure out each of these, let's just put this over a fraction. Q over P. So there you go. And then now I have to obviously invert and multiply, so I'll do that over here. I've got 10 choose 2. I've got 4 choose 2, 4 choose 2. 40 choose 4, and then invert and multiply. 40 choose 4, all over 10. Now the good news here is that these cancel, so I never really needed to figure out the denominator anyways, but it's good to do that just to understand the question. Now let's figure out 10 choose 2, that's 45. 4 choose 2 is 6. 4 choose 2 is 6. And 10. So this gives me 1620 over 10, and that is equal to 162. And just in case you were wondering, how did you get 45 from this 10 choose 2? In case you're not familiar, A choose B is calculated as A factorial over A minus B factorial all over B factorial. So for example, 10 choose 2 would be calculated as follows. It would be 10 factorial over 10 minus 2 factorial all over 2 factorial. Now 10 factorial is 10 times 9 times 8 times 6, times 7 times 6 times 5 times 4 times 3 times 2 times 1, correct? And 10 minus 2 is 8 factorial, so that's 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And then 2 factorial is just 2 times 1, so that's just 2 basically. Now something interesting happens when you do factorial type fractions is that a lot cancels. you notice top and bottom, all of these guys cancel. So all you're left with is 10 times 9 over 2, which is 90 over 2, which is 45. So that's how I got 45 for 10 choose 2. In a very similar way, when you do 4 choose 2, you'd get 6. All right, so the answer to this question was 162, and therefore number 21 is A. For how many positive integers n less than or equal to 24 is n factorial evenly divisible by 1 plus 2 all the way to n? So we want n factorial to be divisible by 1 plus 2 plus n. Well, I'm sure you remember that if you have the sum of consecutive numbers up until n, that can be calculated with the formula n times n plus 1 over 2. So this is n factorial over 1 times 2 times n plus 1 if you invert and multiply. Now n factorial is n times n minus 1 factorial, like that, and then you got the 2 there. And I did that because that allows me to cancel out the n's. So this basically boils down to just 2 times n minus 1 factorial all over n plus 1. All right, now I've got to figure out for how many values of n less than or equal to 24 is this expression an integer. That's the only way this will work. The only way that this is n factorial is evenly divisible. Okay, so let's make a little table here. We've got n, and we've got this expression, 2 times n minus 1 factorial all over n plus 1. And in this table, hopefully, without having to do all 24, because remember, we have to figure this out for everything from 1 to 24. Let's see what we get. Okay, here we go. So we got n equals 1, 2, 3, 4, all the way till 24. So let's start plugging away. So for 1, this expression becomes 1. For 2, this expression becomes 2 over 3. For 3, it becomes 1. For 4, it becomes 12 over 5. For 5, it becomes 8. For 6, it is some fraction, 34.2 approximately. For 7, it becomes 180. For 8, it becomes 1120, like that. And so on, right? I mean, you get the point. But one thing I started noticing is that when I did it for n as odd numbers, I was getting a integer every time. You notice that? But then when I started using even numbers, I started getting fractions. But then I got an integer, but the pattern kind of fell apart there. I thought, okay, even and odd, that will be the difference, but it doesn't seem to me. So what is the pattern in this question? So I stared at this for a while, and I looked at the question again, and I realized that it has to do with this denominator. If that denominator is a prime number, you will not get an integer for this expression. So, for example, when n is 2, the denominator becomes 3. Correct? That's why we didn't get a integer. When n is 4, this one right here, the denominator becomes 5. When n is 6, the denominator becomes 7. And you notice these are all prime numbers. But when n is 8, the denominator becomes 9, but 9 is not a prime number. That's why we're able to get a integer. So we have to figure out what values of n give us prime numbers for the denominator. And that would be, I think, 10. 10 would give you 11, right? That's a prime. 12 would give you 13 as a denominator, and that's a prime. 16 would give you 17 as a denominator, which is prime. 18 would give you 19 as a denominator, which is a prime. 20 is 21, but 21 is not a prime number, right? So that, I don't know why I even bothered with that. 22 is 23. That's a prime number. And I think that's it. So how many primes? 1, 2, 3, 4, 5, 6, 7, 8. So for 8 of these, you will not get an integer. So since there's 24, you have to subtract those 8, and the remaining 16 will give you an integer, and therefore this expression shows divisibility. So that's an interesting question. So number 22, the answer is 16. And that would mean choice C. In trapezoid A, B, C, D, we have AB parallel to DC, E is the midpoint of BC, and F is the midpoint of DA. The area of ABF is twice the area of FECD. What is AB over DC? So let's first draw a diagram. So we got DC, and then I'll draw DA, and then C to B, and then finally join those. All right, let's label this now. So A, B, C, D, and then of course I've got to draw midpoints. So let's see here, approximately here, and that will be F, and that will be E. So let's start labeling everything. AB is parallel to DC, yes. Put a little parallel sign there. E is the midpoint of BC, okay, so that makes that and that equal. F is the midpoint of DA, okay. And the area of ABEF, that quadrilateral, I guess, or that itself is a trapezoid, ABEF, is twice the area of FECD. And then we have to figure out AB over DC. All right. Well, first and foremost, are you familiar with trying to figure out the area of a trapezoid? If you're not, no problem. I'll review this for you pretty quickly. So here's a trapezoid, and this black line represents the height, H. And this is A from here to here, and this distance is B. The area of a trapezoid is A plus B over 2 multiplied by H. All right. So we will basically use that formula on this equation that was provided to us by the question stem, basically. So ABEF will be FE plus AB all over 2 and times our height. Now, I've got to draw in a height here, so I'll do that. Let's see here. The height I'll draw it from D like that. Now, what's interesting is that since this FE are midpoints, it would cut that in half. So I'll call this H over 2, this distance from here to here, and this distance also is H over 2. Not perfectly drawn to scale, but that's okay. All right. So for ABEF, the height is actually H over 2, based on how I designated it. And then that's equal to 2 times FECD. FECD would be DC plus FE all over 2 times H over 2, like that. All right. So that's how you set this up. Now the H's interestingly cancel. All of this stuff cancels here. The H's cancel, the 2's cancel, and so do these halves here in the denominators. So when you remove everything that cancels, all you're left with is FE plus AB is equal to 2 DC plus FE. All right. And if you multiply this out, you'll get FE plus AB is equal to 2dc plus 2fe, like that. So AB is equal to 2dc plus fe. And since we want AB over DC, I'm going to divide through by DC, since that is what they want us to figure out. If you do that, you'll get AB over DC, which is exactly what they want. The DC's cancel, and all you're left with is FE over DC. All right, so far so good. Okay. Now at this point, you think, okay, where do I go from here? Well, what I did was I kind of looked at the answer choices, narrow it down a little bit. AB over DC is obviously 2 plus something, so it can't be 2, right? Because this cannot be 0, because it's a ratio between the lengths of two sides, and obviously that's not going to be 0. It also can't be 1. This cannot be equal to 1. Why? Because FE obviously is longer than DC. Otherwise, it would not be a trapezoid. It would be like a rectangle. Correct? So if this was 1, then it would be 2 plus 1, which is 3, but we just established that it cannot be 1. FE and DC are not equal. So 2 plus 1 is not possible, so 3 is not possible. How about choice 5? If this is equal to 5, that means FE over DC has to be equal to 3. Okay. Is that possible? Well, let's see. So in a very quick way, I'll draw that again, and let's see if this kind of a possibility can be established. So not perfectly drawn to scale, but that's okay. Let's see if this works here. I'm going to first draw perpendiculars here, and then let's fill in what we can. So we've got D, C, F, E, and we've got A and B. So if FE over DC is equal to 3, let's say DC is 1, that means this is 1 from here to here, and therefore these have to be 1 and 1, let's say. And we're just seeing if this is possible. And then therefore, from here to here is 1, this distance. And if we were to draw perpendiculars from F down, like that, since F and E are midpoints, those two have to be equal. These distances have to be equal. And similarly, this distance has to be equal to that distance. So if that was 1, this is 1. And if that was 1, then this is 1. So let's see here. Is our original equation satisfied? Well, what's the value of ABEF? ABEF would be 3 plus 5 divided by 2 times H. And then FECD would be 1 plus 3 divided by 2 times H. The H's cancel and these 2's cancel. So all you're left with is 3 plus 5, which is 8, is equal to 2 times 1 plus 3, which is 2 times 4. And there you go. This holds. 2 times 4 is equal to 8. So this is indeed possible, and therefore AB over DC can definitely be 5. And therefore the answer to number 23 is C. Let x and y be two-digit integers such that y is obtained by reversing the digits of x. The integers x and y satisfy x squared minus y squared is equal to m squared for some positive integer m. What is x plus y plus m? X is a two-digit number, so let's say it's AB. Y, therefore, since you get it by reversing the digits, will be BA, like that. So for example, if x was 57, y would be 75. Correct? Now, how do you write these out in terms of its actual value? It would be 10a plus b, and y would be 10b plus a. So now let's figure out what we can do with this equation. X squared minus y squared is equal to m squared. So plug these in, you get 10a plus b all squared. Or I think a quicker way is just to factor it, right? Because x squared minus y squared is x, y, y plus or minus. And I think that might save us a little bit of work. X plus y, 10a plus b plus 10b plus a. X minus y, 10a plus b minus 10b minus a, m squared. And let's see what we get here. We got 11a plus 11b. And here we've got 9a minus 9b is equal to m squared. And factor out an 11, you get a plus b. Factor out a 9, and you get a minus b. And that is equal to m squared. So that means that this is a perfect square. If it's a perfect square, how do we get that? Well, if this was 11 and this was 9, then that would become a perfect square, right? 11 squared times 9 squared. Well, let's see if that works. A plus b is equal to 11. A minus b is equal to 9. So if you add these, you get 2a is equal to 20. Therefore, a is equal to 10. Ooh, that's not going to work because a has to be a digit, single digit. Okay, no problem. That just means that didn't work. How else can I get a perfect square? How about if this was 11 and this was 1? I think that would work, right? Because 9 is already a perfect square. So 11 times 11, and 9 is like 3 squared. That would work. So let's do this again. A plus b is 11, and a minus b is 1. If you do that, we get 2a is equal to 12, and therefore a is 6, and therefore b is equal to 5. There you go. We got it. Great. A is equal to 6, b equal to 5. Now what do they want here? They want x plus y plus m. Okay, x plus y plus m. All right. So we have to obviously figure out x and y. So a was 6 and b was 5. So our x, therefore, is 65, and our y is 56, and our m squared is equal to x squared, so 65 squared minus 56 squared, and m is therefore 33. So x plus y plus m would be 65 plus 56 plus 33. So I guess I can put it here. 65 plus 56 plus 33, and that is equal to 154. And therefore, number 24, the answer is E. A subset B of the set of integers from 1 to 100 inclusive has the property that no two elements of B sum to 125. What is the maximum possible number of elements in B? So we've got some sort of a set, and it obviously has numbers from 1, 2, 3, 4, ... all the way up till 100, 99, so on. And what they've basically said is that this is our full range of numbers, but we are not going to use all of them. We're only going to use a subset of numbers. And they don't tell us how many either. That's actually what we have to figure out, the maximum possible of numbers. And the rule is that when you finally do figure out what B is, that subset, no two numbers in that subset can be equal to 125 in terms of their sum when you add them up. All right, so for example, if one of them was 100, we can't have a 25. If one of them was 99, you couldn't have a 26. Does that make sense? Because that would be 125. That would be 125 if you added them. All right, so that makes me think that a lot of these big numbers are no good. So if we bring this list down to, say, 63, right? If you keep going here, 63 plus 62, that equals 125. So if I don't include 63 and I go down to 62, I think I should be okay. Because 62 plus any number less than 62, like even if it's 61, will be only 123. So that makes me think I've got to eliminate all the numbers that are from 63 ... all the way to 100. So these guys are all gone. And that just leaves me with 1, 2, 3, all the way up till 62. And therefore this subset would have 62 numbers in it. And I believe that's it for number 25. So the answer is C.